Hello everybody. Welcome to all of you at today's lecture. Today's lecture is basically on the higher secondary physics second paper, chapter 9 atomic model and nuclear physics. Learning outcomes of this chapter: the concept of atomic structure, different atomic models, Thomson model, Rutherford model and the Bohr model. Radioactive particles, basically a brief discussion on the alpha, beta and gamma particle. Radioactivity and radioactive decay, stability of a nucleus and binding energy. We also include here the mass defect, binding energy per nucleon. Okay, let's go to the next slide. The outcomes of today's lecture: the concept of atomic structure. As we already know, atoms consist of three basic particles. Simply we can say the basic constituents of atom are electrons, protons and neutrons. As we know, the proton and neutron are stay within the nucleus. The nucleus means the core portion of the atom. Outermost region is often considered as the electron shell or the electronic shell or orbits. Basically, electrons stay within the orbit. As you can see here in this figure, the proton and neutron are within the nucleus, colored here the green and red. On the other hand, the electrons are staying within inside the orbit. Here the yellow color denotes the yellow balls denotes the electrons. The comparison among the elementary particles, we can compare among them on different parameters. One is the position, charge, amount of charge, mass. Okay, the first, for the electron, the position of the electron within the electronic shell or the orbit. On the other hand, proton and neutron, both of them stay within the nucleus. The charge, we already know the electronic charge is negative and the charge of proton is positive, but unfortunately there is no charge exist for the neutron. Since there is no charge exist for the neutron, the amount of charge of the neutron is zero or not applicable here. Or the electron and proton having the similar amount of charge, 1.6 into 10 inverse 19 coulomb. If you compare among the electron, proton and neutron based on their mass, then we can see the mass of electron is very lighter with compared to neutron and proton. The mass of electron, as we see here, the 9.1 into 10 inverse 31 kg. On the other hand, the proton and neutron having approximately similar mass, not exactly same, but we can say here 1.67 into 10 inverse 27 kg. Here we explain the mass in another unit that's called the atomic mass unit. It's nothing but a carbon 12 based mass defining term that's simply called the AMU. If we convert this mass of electron into AMU, that means the atomic mass unit, then the value is 0.000548 AMU. The mass of proton is 1.00727663 and the mass of neutron is 1.008664. We must need to remember that 1 AMU or 1 atomic mass unit is approximately equal to 1.66 into 10 inverse 27 kg. And how we are able to convert this mass in kg into the atomic mass unit? Then we just need to divide the mass in kg by 1 AMU equivalent mass. That means mass in kg divided by 1.66 into 10 inverse 27 kg. Applying this procedure, we are able to convert any mass into atomic mass unit. Okay, let's go to the next slide. Few quantities related to the atomic structure. Our first term is AMU. We already have discussed but here we explain it clearly. As we see here, the AMU stands for the atomic mass unit. It's a carbon 12 based mass measurement system considering the mass of the carbon 12 is exactly equal to 12 AMU or 12U. That means the AMU or 1 AMU is equal to the mass of 1/12 of carbon 12 nucleus. Then 1U equal 1 divided by 12, that means 1/12 of carbon 12 nucleus just equal to 1.660539 into 10 inverse 27 kg, or approximately 1.66 into 10 inverse 27 kg. As we know, the physics is the study of energy and matter. Then we need to convert this mass amount of 1 AMU or 1.66 into 10 inverse 27 kg, that's into the energy. We need to know what's the equivalent energy of one atomic mass unit. If we want to convert this mass into energy, then we need to use Einstein's mass energy conversion formula. The mass energy conversion formula is E is equal to mc square. Why we say this as the mass energy conversion formula? As you see in the left side, the E that denotes the energy or the produced energy, and m means the applied mass, and c is the speed of light. Here our amount of mass is 1 AMU or 1 atomic mass unit. We need to convert this amount of mass into energy. That's 1.66 into 10 inverse 27. We just put the value of mass into E is equal to mc square equation and put the value of the speed of light, 3 into 10 inverse 8, 3 into 10 to the power 8, and by calculating this equation, the value we get 1.494 into 10 inverse 10 joule. We need to remember there are different units to define the energy. Our most common unit or the SI unit is joule. We often use the electron volt, and the most common unit for this atomic and nuclear physics, that's the mega electron volt, that's MeV. Now we learn how to convert these units. If we divide the energy in joule divided by the charge of electron, as we know the charge of electron is 1.6 into 10 inverse 19, then it just converted into the electron volt. And if we divide this electron volt by 10 to the power 6, that's converted into the mega electron volt. We can see here the final value 933.75 mega electron volt. That's the equivalent energy of one atomic mass unit, and it's our theoretical value or the calculating value, but the experimental value is 931.5 mega electron volt. Then we can write here the one atomic mass unit or 1U equivalent energy is 931.5 mega electron volt. Okay, no more today. See you with you in the next class. Thank you.